All right, I think the audio is fine. Pause this. All right, let's share the screen. Let's see if we got a few more. Okay, share the screen. Okay. My dog is in sleep for hours. She sees me starting my stream and she want to warm up the vocal cords. Come here. All right, so welcome, gentlemen. So we're rapidly approaching the home stretch. Exam 2 is outlined in the syllabus as far as the date. Well, basically, when we get to the end of chapter 4, I think there are 7 sections. I think we're going to do a total of 6 of the 7. I think that's it. Let me kind of pull it up. Yeah, we're starting on section 4.3. We're going through 4.6, right? So at the end of next week will be the last of the new material. So we have this week, and basically we're doing one section a day, right? So today we're doing 4.3, Wednesday is 4.4, next Monday is 4.5. Next Wednesday at 4.6 is the last of the new material for the entire semester. All right, so next Wednesday is the last of the new material. The following week, exam 2 will become available on Wednesday. That Friday is a holiday, but that doesn't pertain to you guys because we don't meet on Fridays. And then the last couple of weeks, we're going to be preparing for the final. So just reviewing. We have 4 chapters, so we'll probably focus on a chapter a day, and we'll just go through any questions. You guys can ask me questions about anything that's on Pearson, right? And we'll take some time to go through it. I'll give as much energy and time as I can. Okay. So that kind of puts it into perspective. I mean, when I say we're rapidly approaching the end, like again, the last of the new material is next Wednesday, right? So, anybody like want to share anything? Like got any interesting stories or anything? A couple of things I kind of wanted to share. It's just random stuff, right? I've watched. I mean, I ain't gonna lie, it's a little bit weird, but like there's this movie on Disney Plus called Turning Red. I actually liked it. It was kind of good. There was that one, and then on Netflix there's this movie called The Mitchells versus Machines. I like both of those movies. They're just animated, you know, feel good family kind of movies, family and orientation. So just random stuff. Okay, so with that, let's kind of hop into the material for today. So we're continuing chapter 4 on integration, right? Again, as a quick recap, integration is like the reverse of differentiation. So we take the derivative that tells us information about the slope of the tangent line at a point on a curve. We also saw some applications of the derivative. And so with this one, we've been looking at, given the derivative, how do we undo it, right? So we're just going to be, and that's called integration, or finding the antiderivative, right? So with this section 4.3, area and definite integrals, that's what we're going to be focusing on. And a few objectives. We like to find the area under the graph of a non-negative function over a given closed interval, evaluate a definite integral, and solve applied problems involving definite integrals. Okay, let's keep going. So to find the area under the graph of a non-negative continuous function f over a closed interval AB, find any antiderivative capital F of x. The simplest is the one for which the constant of integration is 0. So what that's referring to is like in the previous sections, we took the integral and we always added this plus c. So when we say definite integrals, you're going to see it in just a moment. We have these subscript and superscript. So basically, we're taking the integral over a closed interval, right, with some endpoints, right? In the previous examples, we were just doing a generic integral, and that's why we had that plus c, because there are infinitely many possible solutions that get stuck on a certain form. So now we're going to kind of narrow it down to like going from one x to another. The second step is to evaluate the antiderivative of f by using b and a and compute the antiderivative of f at b minus the antiderivative of f at a. The result is the area under the graph over the interval, over the closed interval AB, right? That's a mouthful. I feel like it's easier to see that in action, right? So here we're asked to find the area under the graph of y equals x squared plus 1 over the closed interval from -1 to 2, right? Find the area under the graph. Cool, this is still here. All right, so I got a solid 4 minutes before 6:15 now. Find the area under the graph. So basically what they're asking us to do is to find the integral as x goes from -1 to 2 of x squared plus 1. Let's do it like this, dx, right? Basically find the integral, right? So this is what we have been doing all last week. So for instance, the integral of x squared, you add 1 to the exponent and divide by the new exponent. So that's going to give us x cubed over 3. The integral of 1 is just going to be x. Normally we will put plus c, but now what we're going to do, we want to evaluate this as x goes from -1 to 2. Okay, so this is a repeat of last week with this added portion over here. Okay. And we know that this integral is correct because if we take the derivative of this expression, we get back to the original, right? Okay, so if we keep going, so now we just plug in when x is 2, so that's going to be 2 cubed over 3 plus 2. Then we say minus when x is -1. So we're going to say -1 cubed over 3 plus -1, right? So we plugged in when x was 2, we get an answer. We're going to say minus when x is negative. We plug in when x is -1 and we get an answer, right? That's all that we're doing. So then 2 to the power of 3 is what, 8? So we get 8 over 3 plus 2. Let's see, that's going to be minus, that's going to be a -1/3 minus 1. If we distribute that negative, we'll get 8 over 3 plus 2 plus 1/3 plus 1. Okay. Let's see, 8 over 3 plus 1 over 3 is 9 over 3. So that's 3 plus 3 is 6. Okay, it wasn't too terribly bad. I don't want them. Six, right? So our claim is that the area under this graph of x squared plus 1, as x goes from -1 to 2, the area under the curve on that closed interval is 6 units. Find any antiderivative. We choose the simplest one where we let that constant of integration be 0. We got this, okay? And then evaluate basically when x is 2 minus when x was -1, and using the 6 there. Let's try another. A quick check. Again, usually I leave the quick checks as exercises for you. We got a solid minute and 10 seconds, so let's keep going. Let's do one more. So we have a definition here. So let f be any continuous function over the closed interval a, b, and let capital F be the antiderivative of f, right? Then the definite integral of f from a to b is the integral from a to b of f of x dx. It's going to be the antiderivative of f of b minus the antiderivative of f of a, right? This is essentially what we just did in the previous example. Okay. So here, yeah, let's keep going. We're asked to evaluate this. Okay. So let me start by getting a copy of the original. We had this integral from a to b of x squared dx. Okay. The integral of x squared is x cubed over 3. Normally we would put plus c, but now we want to evaluate this as x changes from a to b, right? So then this is going to be b cubed over 3 minus a cubed over 3. Since they didn't give us a and b, this is as far as that we can take it. Now I have this urge to like gossip a little bit. In the sense that the whole thing with like Will Smith, I was like, man, that's tough. Cause like I totally get Will's sentiment, like after all that crap. You know what I mean? Like, not that I condone it or anything, but I get it. And it's like that's tough. And I had to apply Chris Rock too, because he didn't press charges. I was like, yeesh. You know, but that's tough. Like that stuff, I just send them love and light because I've been there. I don't know if I had that much grace and poise, but that stuff, you know. And it's tough. It's already tough to like be in relationships, just flat out, right? And through all that chaos and that they experience, they still are trying to work it out. You know, lesser people will like not lesser, but that's not the right connotation. But different other people wouldn't. They would just give up. You know, at the drop of a dime. So I just think that that's interesting. Okay, let's I think we finished this one, right? Let me check. Right here, right? Yeah, you see it there in the center. It's convenient to use the interdeterminate. It's convenient to use an intermediate notation. That's fine. Yeah, that's what I did. Okay. Okay. Let's check attendance and see if we got any stragglers. Looks like we got one. Get on these other students to see if they intending to finish or not, and I gotta see what to do about them. Let me let them in. And check the chat real quick. Yeah, I don't know. Did you like them? Like, did you have any thoughts? Oh, I can't right now. Did you have any thoughts on those movies? I'm just curious. Just again, just random stuff. Okay, so we made it through example 2. All right, let's keep going. And then the other thing about the will thing is like, you know, as comedians, that's you know, that's the territory, right? You know, it's like nobody's off limits. It can't be okay to joke about one thing and not the other. You know what I mean? That's just tough. That's tough across the board. I'm just like, eesh. I say give him a pass because it's COVID and you know the war and everything. It's just a lot. I just like forget about it. Speaking of Will Smith, this is the other last thing. He also has a series on Disney Plus called Welcome to Earth. I really enjoyed that series. It's like it's this whole adventure thing. So that's probably what I'll be doing soon. Okay. Evaluate each of the following. Let's see. Okay. We might not need it more space. Let's try to work here. So for instance, the first one, if we take the integral, that's going to become what? X cubed over 3 minus x squared over 2. We want to evaluate that as x goes from -1 to 4. So when you plug in 4, what does 4? 16, 40 plus 24, 64. 64 over 3. 16 over 2. That's when we plug in 4 minus, now we got to plug in -1, so that's going to be a -1 over 3 minus 1 over 2. Okay. So let me give myself some space. I'm trying to jam it in here. Let me add a page. How I want to copy this. We can just take this as the base. Work with that right now. B. Properties. Free to unmute yourself if you have like questions, comments, or concerns about things. That's good. So let's finish this one for now. Here, let me just go ahead and do these other two. Crop. Can we just move it around? Yeah. Do we need this? No, we don't need it. Okay, so this one, all right, we had just done it. Let's just redo it. So then x cubed over 3 minus x squared over 2, evaluated as x goes from -1 to 4. Okay. 4, 64 over 3 minus 16 over 2 minus -1 over 3 minus 1 over 2. Okay. Let's leave we got 64 over 3. That as 16 over 2. Then that's going to become plus 1 over 3 and plus 1 over 2. Okay. 65 is 11 over 3 over 2. Okay. Later. By 1 in the form of 2 over 2. This one by 3 over 3. 130. 130 over 6 minus 30 over 6. Over 3. Even like a rectangle, I had to draw a rectangle first and then resize it. Because if I draw like a square, it gives me a square that I can't manipulate it. Okay, so we got this 50 over 3. We're going to let that be. Speaking of B, let's bring it down. Undo. Okay. Let's try this one. Here, let's like this. Okay. So E, right? Right. So we might be tempted. I think this was fine. And then when we take our integral, we just want to check it real quick. So this one should be what? E to the x, because the derivative of e dx is itself. We want to evaluate this x goes from 0 to 3. So this is going to be e to the power 3 minus e to the 0, which is actually just 1. I'm going to leave it like that. And let me just copy this. Copy and paste. Okay. And then let me grab this C. I kind of want to do a PJ, but I can't think of a good one that I want. If you want to hear a PJ, let me know and I'll do one. PJ is a poor joke or dad joke, right? If you want to hear a dad joke or a poor joke, just let me know and I'll see it. Okay, let's do this one. The integral of 1 that's a constant is going to be x, right? The integral of 2x is going to be x squared, 2x squared over 2, which just boils down to x squared. And I think that one is natural log, right? Minus ln x. We want to evaluate this as x goes from 1 to e. Okay. So then, is this on another page? No. If we plug in e, that's going to give us e plus e squared. Natural log of e is what? 1. So it's going to be minus 1. We're going to say minus, now we plug in 1. 1 plus 1 minus 0, right? So let's just combine like terms. We'll get e squared plus e. Let me see. If we distribute that negative, This is going to cancel this one, but then one is going to persist. So then minus 1. That's the exact result. Then we can use our calculator to crunch that number. I'm just going to stop here. Okay. So here are our results. We got 50 over 3 EQ. That's difference to cube. That could be factored, but I don't know if that helps us or not. But we got E cubed minus 1, and then E squared plus E minus 1. What does it say? I think we're just evaluating. Yeah. Okay, let me get rid of this stuff. And I guess I'm done with this. Delete, because we got A, B, and C. Okay. Let's see, how do we do? So now we got 50 over 3, 6. That's something's off. So we didn't do something right. Maybe not. 14 and the 6th. We got 64 minus 8 plus 1/3 plus a half. Plus 1/3 plus a half. So we did minus. Yeah, we got the minus there. 65 over 3. Negative 15 on 2130 over 6. Oh, there it is right there. 15 times 3. I put 30. I thought it was times 2. 45, right? So that's what happened there. Let's just fix that. So this should have been 45. For the changes. So this is 45. 30 is 100. So 1585 over 6. But 13. There's 85 over 6. Or okay. Then let's see. I think they got 14, 60. This is still off. It's another 15 is 85. Yeah, 60 plus what, 24 is 84. Yeah, we're good. We're good. Okay. The changes, I put them in red, right? Because I think we, right here, we did 15 times 2 instead of 15 times 3. So we had the wrong number there before. Okay, that's fine. We got E cubed minus 1. Use a calculator for the remainder, and then square plus E minus 3. Uh-oh. And oh, they don't cancel each other out. I'm like chock full of mistakes. I'm totally distracted today. Yeah, because it's gonna be minus 1, minus 1, minus 1, which is minus 3. So we got that part wrong too. Do it by hand because I just need to practice. Like if I'm not doing it with you guys, I'm generally not doing it. Unless project or something. Well, but you get the idea. Like we messed up on the arithmetic some, but the main idea was there. And I think it's okay. Let me check Zoom really quickly. Student. Oh, I gotta log back in. What's the time? Okay, that's fine. I think I am loving these longer daylight hours. Let me let them in and check the chat. Okay, let's go here. So the quick chat, again, we leave as an exercise. Okay. Let me see. So then we have this, it says the fundamental theorem of integral calculus. If a continuous function f has an antiderivative f over a closed interval ab, So when we first introduced antiderivative, we had a curve. We broke the curve up like between 2 points into equal, you know, partitions or whatever. Like if we went from 1 to 5 and we broke it up into like 3 equal parts or something like that, or 4 equal parts. And then we drew the boxes. That's what this first part is referring to. That's the Riemann sum. That's the Riemann summation, right? So if we had those boxes, all right, this was the height, this is the change in x, and we added up the area, so the length times the width, and added up all the boxes. Now, and notice when we first introduced those, the smaller the boxes were, the better the accurate, the more accurate the approximation. So then, what if we made those boxes like infinitesimally small, like super thin? That's what this is. So let the limit as n go to infinity of those sums occur, right? So this is basically taking those boxes and making them really small. You don't really. This is just giving you context of where it's coming from, but basically taking the limit as n goes to the infinity of those boxes, basically those infinitesimally small boxes, is the integral. All right. So when we take the integral, it's automatically doing this. The definite integral. The integral as x goes from a to b of f of x dx. So what we were doing today is this guy, right? You don't have to do anything with it. We were already kind of using it. Okay. So let's try it. Let's see this in action. So suppose that y is the profit per mile traveled and x is the number of miles traveled in thousands. Find the area under this curve as over the closed interval from 1 to 4 and interpret the significance of this area. We got the number of miles and the profit per mile. All right, so if that's the profit per mile, I think that's going to give us the like total profit. When it asks us to find the area under the curve, they're basically asking us to find the integral. Take the integral, right? So they want us to find the integral as x goes from 1 to 4 of basically dx over x. This integral is natural log. Again, last week we were saying plus c, but because we're doing this definite integral, because of this part here, instead of doing plus c, we're gonna evaluate this as x goes from 1 to 4. That's basically just the log of 4, the natural log of 4, because the natural log of 1 is 0, right? So whatever that number is, and that should be the total profit earned from 1 to 4, between 1 to 4 miles. That point to crunch that number. Let's see. Integral, yeah. So then we see it there, and then you should calculate it to crunch that number. The total profit of $1,386.30 when miles increase from 1,000 to 4,000 miles. Okay. Definite integral. Predict the sign of the integral by examining the graph and then evaluate the integral. So what they're asking us to do is graph this, all right? So notice that the highest exponent is 3, should be an S-shaped curve. The leading coefficient is negative, so that means our graph should go down to the right and up to the left. And then we have a y-intercept of -1. You can just use a graphing utility to look at this graph. So I think we have one prepared here. And then, so what the integral does, it tells us the area under the curve in regards to the x-axis, right? So then above the x-axis, if we're going from -1 to 2, we have this brown portion above the x-axis, and then we have these two like orange portions below. So more of the graph is below the x-axis than above. So when it asks us to predict the sign, we would anticipate that the sign of the integral will be negative because more of the graph is below the x-axis between -1 and 2, right? Because basically you're going to take the brown area plus this orange area, but the orange area is negative. So you would anticipate the sign of the integral to be negative. Here is that there is considerably more area below the x-axis than above. Therefore, we expect the sign of the integral will be negative. Okay. I guess we could have evaluated the integral. Let's go ahead and do that really quick. So if we evaluate this integral, let me see, x cubed is going to become x to the 4 over 4. So I'm just going to kind of start writing the answer. It's going to be negative x to the 4 over 4. That's going to be x squared over 2, so plus 3x squared over 2. Integral of negative 1 is what? X. And we want to evaluate this as x goes from negative 1 to 2. So again, when x is 2, 4 times 4 is 16. So that's going to be a negative 4 plus 4 over 2 is 2 times 3 is 6. So when we plug in 2, we get that. We're going to say minus when we plug in negative 1. That's going to be a negative 1 over 4 plus 3 over 2. Okay. 2 minus, let me see, 6 times, let me see, 2 over 2, 6 over 4, so 5 over 4. So minus 5 over 4. Over 4 minus 5 over 4 is 3 over 4. Wait a minute. It's 5 over 4. Am I making a mistake again? Let's say we halfway. Okay, thank you. So when we plug in the 2, 2 times 2 is 4, times 4 is 16 over 4. So 4. That's no. 6 minus 4 is 2. Oh, I'm missing. I see where I made my mistake. I'm missing. I didn't see that final x, so I need to go way back. We got to get rid of all of this. Let's delete. I'm kind of moving too fast and writing a little bit too small. Let me just start over because I realized I missed the next. Because I was like, we anticipated the integral to be negative, and we weren't getting a negative. I was like, wait a minute, what did I miss? Okay, let's try this again, right? So when we plug into 16 over 4, 4 divided by 2 is 2, so that's plus 6, right? And then we missed this minus 2 here. That's what we were missing. Then we're going to say minus, so now we plug in negative 1. That's going to be a negative 1 by 4 plus 3 by 2 plus 1. Okay. So is that 0? So it looks like all of this goes to 0. Let's see. Let's go ahead and distribute our negative. We'll get a common denominator of 4. This is going to be negative. That's going to be negative. This one stays. So 3 times 2 is 6. And so then negative 9 by 4. There we go. That's better. Can we paste still? Oh, negative 9 by 4. And so I know last class a student had a question. That question should be answered now because it's basically the same thing. It's the stuff that we've been doing all day. Like I noticed the question. I was like, well, only reason I didn't answer it because we hadn't talked about it yet. But it was okay. But I was like, it's essentially the same thing. You just had to evaluate the endpoint. So we say the first one minus the second one. Oh, I guess that's fine. I'm gonna leave that off. So we got negative 9 by 4 here. Yeah, 4 times 2 is 8 plus 1. Yeah, same thing. And clear, just feel free to unmute yourself or type in the chat. I periodically check the chat. For a faster response, just unmute yourself. Looking at this example, Northeast Airlines determines that the marginal profit resulting from the sale of X seats on a jet travel from Atlanta to Kansas City in hundreds of dollars is given by this. This is what the marginal profit. Find the total profit when 60 seats are sold, right? So basically, they're just asking us to integrate. If we want 60 seats, we're going to integrate from 0 to 60. That'll give us the sum of the profits of selling 0 seats up to 60 seats, right? Okay. So some space. I'm going to add a page. So what they're asking us to do, batteries are gonna low. You figure out how to get the battery life. Now see, it's like in one hand, I want to embrace the technology and like, okay, well, how can we get the battery life of these devices to last longer? But then after watching Mitchell's versus the Machines, I'm like, well, is that a good idea? Should we be? And it's like, with all of this technology, until we reach singularity is supposed to be where basically the technology gets smarter than us and we can't control it anymore. But until then, it's like the technology is an extension of the user. It's not the technology itself, it's the users to a degree. Aside from like radiation, some other things, but it's really the user. Hopefully the audio should still be okay. Okay, let's keep going. All right. So again, we're asked to evaluate this integral as x goes from 0 to 60 of root x minus 6. I'm going to put this in parentheses dx. Okay. So I'm going to do the following. We got the integral from 0 to 60 of x to the power of a half minus 6 dx. Okay. I just rewrote that square root. So now we can use the same technique, add 1 to the exponent. So that's going to become x to the 3 halves over 3 halves. Nope, that's not 3 halves. Over 3 halves minus, I think that's just going to be 6x evaluated from 0 to 60. Okay. Okay, I think this is okay. So then we plug in 60. I might just use the calculator at that point. So I'm going to say 60 to the power of 3 halves over 3 halves minus 6 times 60. Okay. And then we're going to, if you plug in 0, I think that second term is just gone. So we just got to evaluate this. Okay, I'm just going to use the calculator. Oh, good, awesome. Reload and refresh. My dog is in there just having the time of her life. I don't even know what she's doing. I need to try to sneak up on her and see if I can get a video. She is having a blast in there. I don't know what she's doing or playing with. Okay, so let's evaluate this thing. Let's see. I'm going to do 60 to the power of 3 halves. So notice my use of parentheses divided by 3 halves. Okay. I'm going to say minus 6 times 60. Okay, I think that's okay. Are we losing money from 60 cents? It looks like we're losing $5,000. Yeah, that's what we got. Okay. This is in hundreds. Okay. Let's go back to the question. Can I paste? I don't think so. Oh. So it looks like we're losing money if we sell 60 seats. Okay, let's check one more time. Find the total profit when 60 seats are sold, right? Okay. So we integrate to find P of 60. Negative, right? So when 60 seats are sold, Northeast profit is negative $5,016.13. That is, the airline will lose 5,000 on the flight, right? So they need to get above that. Okay, we got this quick check. Let me check Zoom one more time. Yeah, we can talk about it. Okay. Let's see. So this one, I think this is the last one. It says a particle starts out from some origin. Its velocity in miles per hour is given by this, where t is the total number of hours since the particle left origin. How far does the particle travel during the second, third, and fourth hours? Basically, as t goes from 1 to 4. Okay, so the integral of velocity gives us the position, right? So say you have some position function, some function based on time that tells you the position of an object. The the derivative or the rate of change of your position function is your velocity. Then the rate of change of the velocity is acceleration. So when you go in reverse, you integrate, right? So if we want the distance, then we take the integral here. So we're going to basically do the integral as t goes from 1 to 4 of root t plus t. Okay. So that's going to be t to the power of 3/2 over 3/2 plus t squared over 2 as t goes from 1 to 4. Let me see. So when you plug in 4, square root of 4 is 2 to the power of 3 is 8. So that's going to be 8 over 3/2. Flip and multiply it. 16 over 3. For the sake of space, I'm going to write it as 16 over 3. Okay. When you plug in 4, 4 squared is what? 16. That's 8. Okay. Then we need to say minus when we plug in a 1. That's 2/3 plus 1/2. Okay. Let's get a common denominator. We can get a common denominator of 6. So times 2 is 32. 32 over 6. 48 over 6 minus 4 over 6 minus 3 over 6. Okay. Let's see. 48 minus 4 is 44, minus 3 is 41. 41 plus 32, 41, 71, 73 over 6. 10. Okay. And let me see, there's a 1, 13, 12 is what? 2? And 1 by 6. Miles per hour. So this should be 12 and 1/6 miles. Okay, let's see how do we do. Okay. 1 to 4. Okay. 12 and 1/6 miles. Okay, you see it there. All right. So just as a brief summary, it says, let me see, what's the time? Okay, we got a good amount of time. It says the exact area between the x-axis and the graph of a non-negative continuous function over a closed interval AB is found by evaluating the definite interval, like we did today, where f is an antiderivative of f. If a function has areas both below and above the x-axis, the definite interval gives the net total area, or the difference between the sum of the areas above the x-axis and the sum of the areas below, right? So if we add up all the area above, add up all the area below, and then take their difference, that's going to be the net area. If there's more area above the x-axis than below, the definite interval will be positive. If there is more area below the x-axis, the definite interval will be negative. If the area is above and below, the x-axis are the same, the definite interval will be 0. Okay. All right. So I know I don't really want to stop the stream though. Aside from the one-on-one, were there any other questions? Anybody else? Because if there aren't questions, I kind of want to keep it for about right at about 15 minutes. It's really honestly, class list, I don't know what, 7:15. I really want to keep you for about 20. But we don't have to stay that whole time. Are there any requests? Let me go check them. I think what I'm gonna do is go ahead and stop the stream, and we can go ahead and kind of talk. I'll let you guys go, and we'll talk. There was one student that had questions. Okay, so if there aren't burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Let me stop the stream.